Hi, Edexcel June 2013, and it's question 6. We have a bit of differentiation going on, but we need to solve it by integration. We have a differential equation, d theta by dt equals this. We've got a situation, water is being heated in the kettle at time t seconds, the water temperature is so and so, and there's the function for the rate of increase of the temperature of the water, and we need to solve the differential equation to show that theta is equal to 120 minus 100 e to the minus lambda t. That's 8 marks, and then we've got some substitution to do. Once we've done that, to find a time. So, part A for 8 marks. We need to separate variables and then integrate. This is a standard procedure and nice little process. We'll separate variables, bring the 120 minus theta down below the d theta and take the dt up to be with the lambda, and we get that, and then we integrate to get rid of the dt and to get rid of the d theta. So when we integrate, integral of 1 over 120 minus theta equals minus the log, because we've got the minus theta going on there, minus the log of strictly the mod of 120 minus theta is equal to lambda t plus c. There's our constant of integration. And we need to play around with that to get it somewhere close to the format that it wants. So get rid of the minus sign on the left hand side, put it over here. The c is a constant, so it doesn't matter whether it's plus or a minus constant. And then we unlog it. So we e both sides, e to the minus lambda t plus c. But e to the minus lambda t plus c is e to the minus lambda t times e to the c. And I'm going to get rid of e to the c, and I'm going to call it constant a instead, and rewrite that as a e to the minus lambda t. And then we put in what we call our initial or our boundary conditions. So when t is 0, theta is 20, and we find out what a is. So doing the substitution, e to the 0 is just 1. So we're left with 1 times a on the right hand side, and 120 minus 20 on the left hand side. That gives us a is 100. So our particular solution is 120 minus theta is equal to 100 e to the minus lambda t, or theta is equal to 120 minus 100 e to the minus lambda t, as required. So there's fairly straightforward-ish 8 marks. Okay, so now we've got the substitution to do. So let's substitute the parts that we know. We know that the water reaches 100 degrees, the kettle switches off. So we need to find when the kettle switches off, given that lambda equals 0.01, or 100th. So 100th of t, or 100th of minus t, is minus t over 100. And we need to rearrange that, so take away the 120, change the signs, and divide both sides by 100. We get 20 over 100, or a fifth, is equal to, well, e to the minus is 1 over e. So if we reciprocate both sides, I've got e to the t over 100 is equal to 5, and then take logs both sides. T over 100 gets rid of the e, is equal to log the right hand side 5, so t equals 100 log 5, and put that in the calculator. Now we get 160.94379 and so on, but we want to the nearest second, so round to the nearest second, that's 161 seconds, and the job's done. Nice straightforward example, that, I think, of separating variables and integrating to solve a differential equation. 10 marks. Hope you enjoyed the video. Good luck with your own exams. Check out my other videos. Bye for now.